Did you know that up to 75% of the energy produced in the United States is wasted due to inefficiencies? It's a shocking truth, isn't it? We're talking about an enormous amount of energy, just slipping through our fingers, lost in the ether. This tremendous waste is largely due to the limitations of our current energy conversion technologies. But what if there was a way to turn things around, to capture and utilize that lost energy? Imagine if we could harness even a fraction of that lost energy. Enter the world of nanomaterials. The concept of nanomaterials was first introduced by physicist Richard Feynman in his famous 1959 talk, "There's Plenty of Room at the Bottom." Picture this. It's the late 50s, and Feynman, a curious and innovative mind, is ruminating on the potential of manipulating and controlling things on a very small scale. His musings lay the groundwork for what we now know as nanotechnology. He envisions a world where we could arrange atoms one by one, just as we arrange bricks to build a wall. The 60s and 70s saw the birth and growth of nanomaterials. Scientists, intrigued by Feynman's ideas, began to delve into the nano realm. The journey wasn't easy, though. It was like venturing into a new world, armed with nothing but a vague map and a lot of determination. But, as they say, necessity is the mother of invention. The need to understand the world at an atomic level led to the development of tools like the scanning tunneling microscope and the atomic force microscope. These tools allowed us to see and manipulate individual atoms for the first time. The 80s and 90s brought a surge in nanomaterials research. Scientists discovered that these tiny materials, with their high surface-to-volume ratio, exhibited unique chemical and physical properties. They began to dream up new applications for these versatile materials, from medicine to electronics. The turn of the 21st century marked the beginning of nanomaterials integration into our daily lives. These minute particles found their way into sunscreens, sports equipment, and even our clothes. But perhaps their most significant potential lay in energy conversion. Fast forward to today, nanomaterials have found their way into energy conversion, promising to revolutionize how we generate and store energy. From enhancing the efficiency of solar cells to boosting the performance of fuel cells, nanomaterials are reshaping the energy landscape. They're not just small particles, they're big players in our quest for sustainable energy solutions. And this, my friends, is just the beginning. The journey of nanomaterials is far from over. With ongoing research and innovation, who knows what other wonders they have in store for us? Scene script. Solar energy, one of the most abundant energy sources on Earth, is now being harnessed more efficiently thanks to nanomaterials. Imagine a world where we can tap into the full potential of the sun's energy. Sounds like a dream, right? Well, with nanomaterials, we're turning that dream into reality. But how does this work? Let's dive in. In the heart of a solar cell, photons from the sun's light knock loose electrons in a process known as the photovoltaic effect. These free electrons then create an electric current, which is the energy we use. However, not all photons are absorbed and utilized, and not all electrons make it to the finish line, leading to energy loss. This is where nanomaterials come into play. Nanomaterials, with their unique properties, are being used to increase the efficiency of solar cells. One of the ways they do this is by enhancing light absorption. Nanoparticles have the ability to scatter and absorb more light than traditional materials. This means more photons are absorbed, leading to more electrons being knocked loose and ultimately more energy being generated. But that's not all. Nanomaterials also help in minimizing energy loss. Remember those electrons that didn't make it to the finish line? Well, with nanoparticles, we can create pathways that guide these electrons, reducing the chances of them getting lost or recombining with other particles. This efficient electron transport further improves the energy conversion efficiency of solar cells. And it doesn't stop there. Nanomaterials are also opening new doors to innovative solar cell designs, like thin-film solar cells, which are lighter and more flexible than traditional solar cells. The use of nanomaterials not only improves efficiency, but also expands the possibilities of how and where we can use solar energy. So, you see, nanomaterials are not just making solar cells better, they're revolutionizing the way we harness solar energy. They're helping us capture more of the sun's energy and convert it into usable power, bringing us closer to a future of sustainable and efficient energy. With nanomaterials, we are one step closer to maximizing the potential of solar energy. Imagine a world where electric cars can charge in minutes, not hours. That's the potential of nanomaterials in energy storage. The world of nanotechnology is revolutionizing the way we approach energy storage and fuel cells. Take fuel cells, for instance. They convert chemical energy into electricity and are commonly used in electric vehicles and power sources for remote locations. Traditional fuel cells, however, have limitations in terms of efficiency and cost. Enter nanomaterials. When used in the catalyst layer of a fuel cell, nanomaterials can significantly enhance the performance. For instance, platinum nanoparticles used as catalysts can increase the efficiency of fuel cells, making them a more viable option for widespread use. Now let's shift gears and talk about energy storage. The most common form of energy storage today is the lithium-ion battery. These batteries have made significant strides in efficiency and affordability, but still face challenges in terms of energy density and charging times. Here again, nanomaterials come to the rescue. Nanomaterials can increase the energy density of batteries. How? Well, by allowing for more energy to be stored in a smaller space. This means that with nanomaterials, we could potentially have smaller, lighter batteries that pack the same or even more power. What about charging times? Nanomaterials can also help decrease the time it takes to charge a battery. This is because the small size of nanoparticles allows for faster ion and electron transport. This means that batteries with nanomaterials can charge and discharge more quickly than traditional batteries. Imagine in the near future, electric vehicles that can be charged in the same time it takes to fill up a gas tank, or smartphones that can be fully charged in just a few minutes. This isn't just wishful thinking. It's the future that nanomaterials are helping to build. We're standing on the brink of an energy revolution. Nanomaterials are not just improving our existing technologies, they're paving the way for entirely new possibilities. The future of energy storage, powered by nanomaterials, is not far off. The world of nanomaterials is still largely unexplored, holding immense potential for future innovations in energy conversion. As we delve deeper into this microscopic universe, we begin to realize that the fusion of nanotechnology and energy science could revolutionize our current energy systems. Nanomaterials, with their unique properties and high surface-to-volume ratios, are being explored for their potential to enhance energy conversion processes. For instance, researchers are looking into how nanomaterials can improve the efficiency of thermoelectric materials, which convert heat into electricity. Imagine a world where the heat from your laptop or car engine could be converted into usable energy, reducing waste and increasing efficiency. Moreover, the future of nanomaterials in hydrogen production is promising. By using nanomaterials as catalysts, we can potentially make the process of hydrogen production more efficient and cost-effective, paving the way for hydrogen to become a major player in the renewable energy sector. But like all frontier technologies, there are challenges to overcome. One of the significant challenges is the scalability of synthesizing nanomaterials. Producing these materials on a large scale, while maintaining their unique properties, is a complex task. There's also the question of durability. Many nanomaterials are not yet robust enough for long-term use in energy systems, and researchers are working on improving their stability. Furthermore, there's the matter of environmental impact. While nanomaterials hold promise for cleaner energy, we must ensure that their production and disposal do not harm the environment. Responsible nanotechnology is key to its sustainable future. Despite these challenges, the potential of nanomaterials in energy conversion is undeniable. They represent a new frontier in our quest for sustainable, efficient energy solutions. As we continue to innovate and tackle these obstacles, we open the door to a future where energy conversion is more efficient, more sustainable, and more accessible. As we continue to explore this nano-universe, who knows what energy miracles we might discover next? From their discovery to their current and future applications, nanomaterials are undeniably transforming the energy sector. We've embarked on a fascinating journey today, exploring the world of these tiny particles and their massive impact on energy conversion technologies. Remember how we began? With the birth of nanomaterials, which set the stage for revolutionary advancements in the field of renewable energy. Next, we dove into their role in solar cells, where they enhance light absorption and charge separation, boosting the efficiency of these sun-powered devices. We didn't stop there. We explored their applications in fuel cells and energy storage devices, where they improve conductivity and energy capacity, leading to more efficient and longer-lasting energy solutions. And of course, we delved into the future of nanomaterials in energy conversion. With continuous research and development, these small particles have the potential to solve some of our most pressing environmental challenges and pave the way for a sustainable future. But let's not forget, as with all scientific endeavors, further research is necessary. Every discovery, every advancement brings us one step closer to fully harnessing the power of these small yet mighty particles. The world of nanomaterials is small in size but big in impact. And remember, sometimes the smallest things can make the biggest difference. Don't forget to subscribe to Brainiacata for more enlightening content. Until next time, stay curious.